Chapter 17, Section 1, the reaction process. So in this lesson, we will talk about the rate of reactions. Rate of reactions means speed of reaction. So some reactions occurs more rapidly than another reactions. So why? Speed of reactions depends on what? So first we will talk about the collision theory. So this theory, it used to predict the rate, again rate means speed, of chemical reactions. So there are three assumptions for this theory. Now, assumptions of collision theory. The first one, particles must be collide with one another in order to react. So substances or particles must be collide with each other so the reaction occur. If they don't collide with each other, no reaction occur. So here particles must be collide with each other. Assumption number 2, particles must be in correct orientation, and orientation means direction for a reaction to occur. So particles must be in correct orientation. What means correct orientations? For example, for this reactions, if ozone reacts with nitrogen monoxide, the products are nitrogen dioxide and oxygen gas. So here, one oxygen from ozone transfer to nitrogen monoxide, so nitrogen dioxide produced. So for example, here ozone, 3 oxygen atoms, and here nitrogen monoxide, here nitrogen. So if nitrogen collide with oxygen atom in ozone, so the reactions occur. So nitrogen dioxide produced and here oxygen gas. But if here incorrect orientation, here nitrogen atom and here oxygen. If oxygen collide with another oxygen atoms from ozone, no reactions no reaction occur. So particles must be in correct orientation for a reaction to occur. Again, here for a reaction to occur, nitrogen must be collide with oxygen from ozone to produce nitrogen dioxide. So here in the first case, nitrogen collide with oxygen, so nitrogen dioxide formed. But here in the second case, oxygen collide with another oxygen atoms, so no reactions occur. So the first one, particles must be collide with each other, and the second one, they must be collide in correct orientation. So the third assumption is particles must have sufficient energy for a reaction to occur. So sufficient energy means enough energy. So particles must be collide, and as a collision, the energy produced must be enough for a reaction to occur. So the minimum energy needed for a reaction to occur, it's called activation energy. So energy produced from collision must be equal to the activation energy, which is the minimum energy needed for a reaction to occur. If energy produced from collision less than the activation energy, no reaction occur. So here, let's see some videos about the assumptions of kinetic molecular theory. So here, for the first assumption,
for a reaction to take place, the reacting particles must collide.
So this is the first assumption. The particles must be collide with each other. And here,
orientation. Even if the particles collide with sufficient speed, if they aren't at the correct angle,
here oxygen
no
collide
reaction
with
will
another
happen.
oxygen, so no reaction
In this example
occur.
of nitrogen monoxide and ozone, the reaction didn't occur because the oxygen of each molecule touched during the collision. In this collision of the same two molecules,
Here
the
nitrogen
touches
collide
the
with
oxygen and
oxygen,
the
so a reaction occur. So the second assumption correct orientation. And the third one here, enough energy.
Slowly roll the ball of yellow plasticine towards the ball of red plasticine, they will collide.
So if they gently collide,
However,
no reaction
pick
occur.
up the ball of yellow plasticine.
And here, to understand the meaning of activation energy,
Activation energy is the required energy needed for a reaction to occur. For example, in order for a large rock...
so here, this ball with enough energy, so a reaction occurs, and this ball or particles not enough energy, so a reaction does not occur. So again, the three assumptions of collision theory. Assumption number 1, particles must be collide with each other. Particles must be collide in correct orientation, and energy produced from collision must be enough for a reaction to occur. And the minimum energy needed for a reaction to occur, it's equal activation energy. So, from this point, you have to know that reactions that have higher activation energy, here the symbol, activation energy, so they occur slowly or rapidly. So the rate of reactions increases. So they occur more rapidly. And reactions that have, decreases. So it's occurred more slowly. And reactions that have lower activation energy, it's occurred rapidly. So rate of reactions increases. So here slowly, this means it's occur slowly, and here more rapidly. So if we draw diagram, energy diagram, for examples, here's the reactant and here's the product. So this is the energy diagram, and the energy difference between reactant and the top of the curve, it's called activation energy. So for example, this is for reaction A, and the activation energy for another reaction here, activation energy for reaction B. So here B, reaction B, has lower activation energy, so it's occurred more rapidly. The rate of reactions increases. So again, the minimum energy needed for a reaction to occur, it's called activation energy. And reactions that have higher activation energy, the rate of reactions decreases, so it occurs more slowly than the reactions that have lower activation energy. So here, what is the top of the curve? Indicates what? So the definition here of activation energy, again here from the diagram, it's the energy difference between reactants and the top of the curve. So what is the top of the curve? So activation energy, the minimum energy needed for a reactant to transform into an activated complex. So here the top of the curve here is called activated complex. So what is an activated complex? In any equation, for example, hydrogen gas reacts with iodine gas. The product is 2 moles of hydrogen iodide. So chemical equations indicate the reactants and the product. It does not show the step-by-step sequence of the reactions. So chemical reaction does not show step-by-step sequence of chemical reactions. So step-by-step sequence of chemical reactions, it's called, it does not show the chemical mechanism. Again, if you have any chemical equation, you can show just the reactant and product. This reaction does not occur as simply as you show. So here the reactants first form the activated complex, then activated complex form or transform to product. So this step-by-step sequence of chemical reactions, which is called chemical mechanism, does not appear in the chemical equation.